Okay, so homework assignments coming up for this week. This week you have homework 7, which is your first time trying out interactions. Woohoo! Let me share my screen so you can see what I'm talking about. Okay, here we go. Your interactions assignment will be one continuous outcome and at least 2 predictors. They can both be continuous, or you can have 2 dichotomous, or you can have one of each. You can have more predictors than that if you want to, but 2 is required. You can use the same variables you have before, or you can use different variables. That is your choice. You need to predict your outcome from your 2 predictors and their interaction. Your assignment should include the following information. You need a few background sentences to explain why you're running a regression with an interaction. You need to include a research question that includes the interaction or the moderation question. Include the stats program output, where you get the R squared and then the intercept, the slopes, and the slope, because there's going to be 3 slopes. And I want to see at least one sentence explaining and interpreting what each of those results means. And then I'd also like you to do a graph of the results. And then I have a bonus here, which you can do if you feel like that's not challenging enough. You can recenter your data and do it again, which is what we're going to talk about today. And then the last thing that's required of everyone is, what do the results mean for your research question? 5 things. It's in a similar format to what you've done before. You can write it, either you can write it up straight, or you can think about writing it as an email to the person who gave you your data, or someone else in your lab who would be interested in your results. All right, that's homework 7. That's due on Friday at noon. And then you will have a peer review, so you'll read it. You'll read someone else's, it'll be automatically assigned to you at a peer review at noon. A peer review is assigned at noon, then you have till Monday at class time to do it. All right, the next thing I have on the radar to just put on your radar is, in 2 weeks, you're going to have the first draft of your final project due. And the final project is a submission to the Hayes Graduate Research Forum. And so the guidelines for the Hayes Graduate Research Forum are here. They are slightly adapted for this class because the Hayes doesn't care what kind of research questions you ask. In this class, you have to ask regression-based research questions. You can absolutely do anything you have already done. You do not have to. It can be something totally new if you want it to be. And then these are the instructions about what it should look like. And I'll be posting this tonight after I proofread it and make sure that my introduction to you makes sense. It will have 4 sections that will seem familiar to you: purpose, research method, findings, and implications. So that's results and conclusions, basically. It can be no longer than 1 page or 1,000 words, whichever comes first. So it's real short. You don't get any tables, figures, or illustrations. So it's like just words. It's very tight and condensed. Okay. So this is what it will look like. Attached to this document is also the rubric of how I will grade the final draft. What I want you to know is, like, you should review this draft, this final draft rubric, just so you know how I'm going to be scoring it. The first draft is scored based on completion. If you turn it into me, you get a 10. That's 10 out of 10. It's a regular homework assignment. If you turn it into me and it's just a title and you didn't actually do it, I won't give you a 10 because I want you to actually do the assignment. Do your work. Okay, so if you do this, then you'll have the opportunity to review each other's, have a discussion with each other, provide feedback to each other, and that will start to refine it from there. So you'll turn in the initial draft and then you'll have an opportunity to revise it, and then you'll turn in the final draft. So I will post this tonight, so you will have plenty of opportunity to look at it before the next class.
When's the draft due?
It's on the syllabus, which won't open for me. I don't know if you can see, when I hover here, you can see that it's here. There's my schedule. It's due whatever day the schedule says it's due, which I think is a week from Monday, maybe, but it might be 2 weeks from Monday. I can't remember. So I'm sorry. We'll look it up. Okay. That's your information, your sort of brief overview about this. I don't actually know if the haze is going to happen this year. I have looked it up, I have emailed about it, and I have not heard anything yet. So we'll see.
I got an email about it. If you want, I can forward it to you.
You did?
Like
I
2 days ago.
asked about it. Yes, please.
Happy to.
Someone says, Hannah, you said they're due 11/9. That's when this is due?
According to this is the final draft of the final project is due on the 16th, and the rough draft of the final project is due on the 2nd. Where did I get the 9th? I'm lying. I'm sorry.
11/2.
It is the 2nd. Yep.
Okay. And depending on what I hear back from the haze, we may push that date back a little bit because this is a crazy semester. No promises. Just work on getting your rough draft done, and then we'll worry about the next step. We'll talk about it again next week. Okay. Oh, gosh. Okay, can you see this here? Great, we're sharing screens. Now we're going to move on from the last week's homework and research questions. Now we're going to talk about interactions when you have two continuous variables. We've already talked about interactions when you have one continuous variable and one dichotomous variable. And if you remember, what was nice and easy about that is you were able to say, you graph two lines, one for each value of your dichotomous variable. That's how we've been thinking about this before. Today, we're going to cover continuous by continuous interactions. The types of questions we ask, however, are unchanged. So we're still going to be asking, does the relation of x1 with y vary across levels of x2? But you might be thinking, what does it mean to vary across levels of x2 if x2 is a continuous variable? Because before, we've only had two values. We were cars or trucks. And so we were able to ask, is the relation between x1 and y different for cars and trucks? So now, if we have something like this that's a continuous variable, this x2, which ranges from 40 to 64, what it means to vary across levels of x2 is you just think about low and high values of x2. And we'll drill down and get more specific, but it might be easiest to think about when you're low on x2 versus high on x2. So hang on 1 second. Okay. Now, I'm going to walk through an example from a survey called the Library Topology Survey. So this was given in 2013. And this survey has a variable, it was a big survey that they gave out to several thousand people. And they asked people this question about going out places. This is obviously pre-pandemic. It says, do you go out on a regular basis to the following places? Do you visit art museums? Do you attend sporting events, go to concerts, go to plays, go to dance performances? And for each one, you could say, yes, I do this regularly, or no, I don't do this regularly. And so I took a sum of these to get an average here. The average was 6 things. People do 6 things regularly with a range of 3 to 8. Again, pre-pandemic. Now I do 0 of these things ever. Okay, my first variable, I called it inside, but maybe it's more like at-home activities, like stuff you do inside in your house. And they asked, how often do you watch TV, read the news, listen to music, read books? And those were scored on a scale of, I think it was 1 never to, or 0 never to 5 always, or like every day. So more often, a higher score here means more times doing activities inside. I read lots of books every day. I read the news every day, those sorts of things. Now, the next thing I have is this x2 variable, and the x2 is going to be our moderator variable. And this is called find information. And they asked participants how difficult it was to find information on multiple topics. And each one was rated on 1, which was very easy, to 4, very difficult. And I summed these together into a scale called find information, which is continuous. And it goes from 0 to 20, the mean of about 9. So it's adding them all together. It's pretty easy to find information on all these various topics across for all these various people. So we have 3 variables. We have finding information, we have like doing activities inside your own house, and we have going out. Okay, the additive research question, that was the question we would have asked up until we started studying interactions. The multiple regression question is controlling for how often people do in-house activities. Do those who can find information more easily go out more often? The idea behind this being, to me, was for any 2 people who are similar levels of bookworms, if one person has an easier time finding out what's going on in the neighborhood, they'd be more likely to go out and go to museums and stuff. All right, that's my idea here. So the equation representing this idea is the y for going out is equal to the y-intercept plus b1 times inside, the value for inside we want to estimate, plus b2 times the value for find info. Again, this is a multiple regression, just a review for you. So here's all of our additive results. Starting here, I'm going to do them all, and I'm going to do them all individually, so you don't need to read ahead. What I have here is the r squared, which is 10. This is telling me that finding information and activities inside together are explaining 10% of the variance in going out. And then I use my f to back up that r squared. So I'm doing a pretty good job of explaining some of the variance in going out. Now from here, let's move down into these text boxes. So I have for the constant, my y-intercept, this is telling me that when inside and find info are 0, my expected go out score is 8.23. And here, controlling for ease of finding information, those who did more in-home activities report going out less often. That makes sense to me. My introverted friends would much prefer to read books than go to sports activities. And then this one here says controlling for the number of inside activities people do, those who find information more easily are more likely to go out. All right, so far, making sense, I hope, because we're reviewing. I got 2 nods going on. Now we're going to add the interaction term. And if you remember, the interaction term lets us free up a new question, which is, does the ability to find information moderate the relation between at-home activities, which is that inside variable, and going out? You can also ask it the way we asked the engine truck car question, which is, does the relation between at-home activities and going out vary across levels of finding information? Now here's the equation that represents this question, this research question. I still have this part's the same, B0, B1, B2. And now I have my new interaction term, B12 times inside times find information. So what does that look like? What I've done here, remember, to get an interaction between finding information and inside, you have to multiply them together. And so here is the variable for find information. Here is the variable for inside. And when I multiply them together, I get this variable, which I called inside underscore information, or info. So now I have an interaction term that I can put into my model. Now here's the result. The result is actually pretty similar here. We didn't explain much more variability. Inside, find information, and their interaction are explaining about almost 11% of the variance in going out. Now our numerator, degrees of freedom, has 3 now, where before it only had 2 because we have a third predictor that we didn't have before. And now let's do this one. Starting with this first line, 9.2, this is saying that when inside and find info are both 0, the expected go out score is 9.2. So for this next one, inside, remember you have to place it in space, which is why I have highlighted these as red for you. When find information equals 0, increasing inside activity is associated with a decrease in going out activities. Negative 0.226. There's my p-value. And now to do the other one, to interpret this find information coefficient, you have to talk about when the other predictor is 0. So when inside equals 0, those who find information more easily report going out less often. Negative 0.06 is the coefficient here, and I have a significance test. Now this question right here, this is the sort of key to the moderation question. This is what lets you answer the moderation question. So this tells us that the ability to find information does moderate the relation between at-home activities and going out. Because this, even though it's really small, it's significantly different from 0. So we're seeing a significant moderation of this effect. And because we have a significant moderation, it means that our lines are not going to be parallel. But what lines? How do we pick lines? I'll tell you. We're going to pick some spots. We're going to pick a point. That's what we call that. The pick a point approach. So we're going to graph it. And what I'm actually going to do is let you graph it. So if you will pull up an Excel sheet yourself. I don't want to cover this up. If you will pull up an Excel sheet. Oh man, we lost our spot. There we go. If I do this, can you see it? Can you see that well enough to write it? Okay, cool. Okay. So the first thing that you need to do is to write down the regression equation, because that will help you as you are monitoring what to do next. So hopefully, I'm hoping that what you're able to do is have my PowerPoint open on one space and have your Excel file open in the other and work through graphing it. So I'm going to type it and I want you to type along with me so you have it too. So y is going to be equal to plus -2 negative 0.226 times inside plus negative 0.066 times info. Yes, Abby, that is, and Madeline. That's going to come in equal. That's going to come in handy in just a minute. Times info, and then plus 0.008 times both, times inside times info, because they're both there. Ooh, yes. Which font? This font? Wait, I know. Hold up. Yeah. Oh my gosh. There we go. Dun, 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 dun. All right. We've got some numbers. Yes. Oh my gosh. Yes. You guys, this changed my life. Just check in here in the chat here. Hadley's talking about how you can change the zoom on your screen. It really has changed my life. There's a little button up here and you can say like zoom in on the person who's typing. It's very useful. Okay, so now if you remember, the next thing we're going to do is pull each of those pieces into its own cell so that it's easier to multiply it. So we need this, the constant, which is 9.291. We need the inside coefficient, which is negative 226. We need the info coefficient. The reason I'm asking you to do this the same time I'm doing it is because in a second I'm going to make you do different things to it. So you can sit back on your laurels and just watch me if you want to, but I think you're going to be better off in the long run if you write it yourself. All right, inside was 226. The info is multiplied by negative 0.066. And this is the interaction. Inside times info is 0.008. Okay. Now the next thing that we have done in order to do this is we picked some probable values. Before it was easy, we picked 0 because it was 0 in a car and 1 when it was a truck. We can still pick 0 and 1. Those are totally legitimate values. So let's pick those. So this is 0 and 1 for inside. And let's pick 0 and 1 as probable values for information. That will make this math Really easy. All we're doing here is picking which value is going to go for which. What's the expected y for this one, for each of these possible cells. So this one's easy. What's the expected y-score when inside is 0 and info is 0? Anybody know? Excellent. 9.291. Okay. That's what that one is. And what about when it's 1? Let's do this math. So this is going to be equal to, all I'm going to do is recreate this equation. So I'm hitting the equals button, this, plus, following right along, this times, what's this, inside? So I need to pick the inside value, this, plus this times, I need to pick the information value. So I'm picking it here because I'm in this row. And then last is this interaction terms, and it's telling me I need inside and info. So times that, times this, times this. I got 9.065. A couple of you did too. Woo! All right. Now let's do it again for the other two values. I'm going to use copy and paste, which is a terrible idea. I'm actually not going to use copy and paste because I didn't use any of my special numbers. So I'm just going to do it again. So you can watch me do it again. If you didn't do it the first time, you get the chance now. Equals constant plus inside times my inside value plus the info coefficient times my info value plus the interaction term times the info value times the inside value. I got 9.225. Now I'm going to do it again. One more time. Constant plus inside times my inside value plus info times my info value plus inside times info times this times that. All right. This one's gone down some because it's going down for both of these. So now I have enough to make a graph. Let's look. We've got insert. Oh, it looks like, did somebody get a different answer than me on this last one? 1, 2, 3, 4, 5, 6. Okay. No, no. Okay, got it. All right, so I'm going to insert a graph. We have two lines. They look real parallel. Why do they look so parallel? Don't know why. I'll tell you why. How much is this interaction term changing? Our values are really similar. Look at how much it's changing by 0.008. And so this is not useful. I'm going to add in our axes. Horizontal 0, 1. Oh my gosh. I have two values. So here's what we can do. It's not changing very much. They look very parallel because the difference between 0 and 1 is only going to be 0.008. But let's see what happens if I change these to 10 and 10. Look at that. 10 is not a reasonable value on one of those, I think, but we can pretend it is for illustration purposes. Okay. So I have now this scale is going from 0 to 10. When my x value is 10, you can see that what my predicted values are for each one. What I'm going to do now is I'm going to change this axis so that I can see it easier. Oh, you missed how to create the graph. I'll show you. Watch this. Highlight the values you want to make a graph from and click Insert. And then there's this little guy that's a line chart. Line chart. And then it just shows up. I'm going to get rid of this guy. So now I'm going to change this axis because I want to be able to see this up really close. So I'm making the minimum 6 just so that I can look up close at this. Now this is not 1 and 2, so I'm going to fix that by changing the axis. I'm going to do that by selecting the data. I'm going to change the horizontal axis so it goes from 0 to 10 because those are my two values. Now this is going to be the value in the tens place. This is when info is 10, and this is when info is 0. So one of these has a steeper slope. Can you see that one of them has a steeper slope here? It's this one. When the slope here, when info is 10, the slope that relates inside to going out is shallower than it is when info is 0. That's because as this relationship goes up, as this value goes up, the negative slope decreases, or not the negative slope undecreases, gets less negative, more towards positive. Now let's see what happens if, so what's going to happen if I go out to 100? What will happen? Do it to your own graphs first. Did I see how do you do that? You just change this from 10. So I'm going to change mine to 5 and 5. Or we can do 5 and 10. That's fine. If I go out to 100, okay, let me rephrase. Here, when it's 0, who has a higher going out score? Is it the blue line or the orange line? Who has a higher going out score at 0? Yes, this blue line, which is info 0. I'm going to write. There's a way to do this on the graph, but I don't want to, we're doing enough things now. This is the graph we're talking about. Okay, so this is the blue line. You can see that it's bigger. This is a higher going out score for the blue than the orange here at 0. What about at 10? At 10, they're about the same. It looks like, if I could guess, somewhere around 8, they're probably identical. Do you see that? At 8, when my inside score is 8, there's no difference between the two expected going out scores. They're the same. Now remember, it doesn't make sense to go out to 100 because the scale only goes to 8 or 10. One of them went to 12, I think. But if you thinking about those projection articles that we read a couple of weeks ago, if it did go up to 100, who would it favor? Blue or orange? I'm going to type it in. We can't even tell because I fixed the graph. Favors orange all the way down here. And so I'm walking you through this, and these are also not plausible values, right? You can't get a negative 13 on going out. You can only get a 0 to 8. I'm walking you through this to sort of show you that where you center matters a lot, because all we're doing here by plugging in these values is kind of like centering. If I move this one up, look what happens to the slope.
Kiss before I can say anything.
Uh-oh. Does somebody need something? No? Okay. So when my difference between my slopes here for 0 and 1, see the slopes are really similar between my blue and orange lines for info. If my info is 0 or my info is 1, the slopes relating inside with going out are the same, are very similar. But as I move this up to 10, see my blue slope stayed the same because that's still 0 for info. That's still saying when info is 0, the relationship between inside and going out is this steep. My orange line is another point. So I've gone from 0 to 10. If I move it to 15, it gets flatter. If I move it to 20, it's getting more flat. If I move it to 100, it's positive now, which again doesn't make sense because it's not possible. We can't do that. But 10 is possible. So each one of these points is kind of like, remember before we could only say cars or trucks. With something like this, we can pick lots of points because we have lots of points to pick from across this whole distribution of your predictors. So picking 2 to plot is the way that we can get pieces of information to plot on the graph. I see a lot of very confused faces. I'm going to keep talking about this as we move up. There are levels with continuous moderators. These are continuous moderators. I've picked 2 levels. I guess you could call them levels. I've picked 2 points on these continuous variables in order to see how the relationship changes as I move things around. We don't get levels with dichotomous variables. We do get levels on non-dichotomous variables. That didn't make any sense at all. I'm sorry. I said that while I was reading a comment, so let me rephrase. So levels is kind of a confusing word. We've used it to mean different values necessarily, like different value, like cars versus truck could be a level. And then with this one, you can pick what you could call a level. It's just a point. Pick a spot. And you can change these axes with this select data little guy. And then you can pick them here. You can also edit this. Oops. So now that's going to be called 0.0. All right, so that's what this looks like. And I want you to hang on to it because you're going to do another one of these in a minute. I just graphed it. I want to show you one example of this in published data. That's why I have this here. So this is an article on political intolerance, right and left, and it's in the journal Political Psychology. It came out in 2014. This is their research question. To test the hypotheses regarding political intolerance of left-wing and right-wing targets. Targets are probes that they ask, like passages of text. We conducted a series of two-step hierarchical regression analyses on each of 8 target comparisons. Political knowledge, they had all these different things, and they had experimental condition, left-wing and right-wing targets, and they entered them in step 1. And then they have additional variables that they're entering along with the interaction in step 2. Now, I think it was Nina who asked earlier, can you do this? Do you always do this in 2 steps? Or does it matter if you do it in 2 steps or 1 step? And it doesn't matter necessarily. You just get an additional piece of information where you can say that with putting this in as a second step, you get to understand whether it's explaining additional variance or not. It may or may not be. So they added this interaction as step 2, but this is just the results of the interaction analysis. They're telling us that by entering it in at step 2, it's explaining an additional 17% of the variance in R squared. It's not a T. I don't know why they put it in this T space. That's a little bit confusing to me. It's difficult to read. But each one of these, here's your B, your standard error, they are using this to represent their beta or their standardized coefficient. And then you get a t-test for each one. Here's the t-test of the interaction. And then this is the result of the interaction. And they did the pick a point approach, which is what we just walked through by plugging in different values. And they also, you can call this probing the interaction. And it's from this page of the article. That's why that's here. So they're saying that liberal human beings were more intolerant of right-wing targets than left-wing targets. So let's see, I think one of the examples was something like, I believe people should be allowed to immigrate into the United States. And so that would be a left-wing target. So the left-wing people are more tolerant of the left-wing targets and are more intolerant of the right-wing targets. Blah. So hold on. Before I dive really into this, I think I'm going to move on from this example because it's a little bit difficult to explain. I like the example of seeing how they write this up. And I like seeing this interaction. So you can sort of see that these do happen in real life, that you get interactions that look like this in real life when you're analyzing real life data. And so this is why I wanted to bring this up in order to reinforce the point about centering. So when you have an interaction effect, the interpretation of the main effect, not the interaction, but the other variables, can be misleading if you're not placing it in space. Because for either one of these, just the main effect is not sufficient to describe what's going on. Because if you're centered here at 0, you're seeing a small difference between your 2 groups or your 2 lines, which may or may not be significantly different from 0. Here you're seeing a large difference that's favoring the blue. But if this was your 0 point here, you would see that there's no difference here, but there would be a medium size effect if you had an interaction that looked like this. And then here you would see the opposite of what you saw before. So now we're favoring the red, and here you have a much bigger difference. So this is why I'm talking about you always need to position your result in space. You need to say exactly where it is. Because remember, when I was playing with that Excel document, when I changed the input value, the slope changed completely depending on the value that I put in. Now, all I was doing in that Excel document was looking at what the slope looks like with my eyeballs. How do you know if those slopes are significantly different from 0? The way you do that is by probing the interaction. This will let you see, get a better understanding of when the relationship between one predictor and the outcome is strong, is positive, or is negative. And you do that, it's called probing, you do that by picking points, and then you can recenter your focal predictor and test whether the main effect is significant at that point. So on my Excel document, remember I plugged in 10 and then I saw that my slope went from very steep to less steep. What I don't know is whether when I made it less steep, that was significantly different from 0. In order to figure that out, I recenter it and then I run it again. And I'll show you what that looks like. So here are the steps to the pick a point approach. You recenter a focal variable, then you have to recreate the interaction variables with the newly created variables, and then you have to rerun the regressions with the new variables. 3 steps. Remember, this is our equation. It's the same thing we were just talking about, going out, hanging out inside and finding information. If I'm centering inside, because that was our focal predictor before, I want to center it at 10, which is going to represent somebody who does lots of stuff inside. They're reading books, they're reading the news, they're listening to music, all inside their own house. You recenter it at 10 by subtracting 10. And so here I've taken this inside variable and I've subtracted 10 from it to get this new variable called inside 10. We've done centering since week 2. So this is a little bit of a review, but I want to show you what this looks like because I know we had some confusion around centering before. So 9 minus 10 is -1. And 13 minus 10 is 3. Okay, so when inside 10 equals 0, it means that on this other variable inside, they scored a 10. So that was step 1. Next, I have to recreate the interaction variable. So that's going to be my inside 10 times my original find info variable, because I didn't change that one around. And that gives me this new variable called inside 10 info. So that's inside find info times inside 10. That's how I get -6. 6 times -1. So then you rerun the regression with your new variables in the model. These are unchanged from what they were before. Just like when we did other centering, there's no change to your R-squares when you move your centering points around. Now our coefficients look a little bit different. Some of them are different, some of them aren't different. And this is actually what I want you to spend a few minutes right now thinking about. I'm going to put these both where you can see them. This is the coefficient when I have inside centered at 10. And this is the result when I have inside not centered at 10. And these are the 3 questions that I want you to ask. I'm going to really quickly edit this so that you can have all of the results in the same place at the same time. Whoops. I actually don't know that I can do that. You have access to this PowerPoint, right? So you could potentially go back and forth. I already told you that these 2 don't change. So I'm going to give you these 2. Oh, I can do it. Sweet. So I have inside centered at 10, and then I have inside not centered. So I'm going to set a timer for 7 minutes. Is there a specific reason I chose 10 for this example? I chose 10 because it was not the highest possible score on inside, but it was a pretty high score on inside. And because it was a round number that I could multiply easily in my head. That's the only reason. All right, so I want you to compare these two with these 3 questions in mind. And I'm going to mute myself and put a timer on. And then at the end of 6 minutes, I'm going to pop you back into your groups to chat about the answers. Do you still see the thing or do you see your faces? Thing? Okay, weird. Okay, everyone. I'm going to put you into breakout rooms for the same amount of time to chat about the results that you just found to these 3 questions. So if you need to jot them down before you go into this room, take the time to do that before you go into your rooms.
Hey,
Hello.
is this my breakout room?
I guess not. What happened to your breakout room?
I don't know, but I get you and Susan, I guess, so I better have some good answers.
I can put you all in some breakout rooms. Oh, hello. Or that works. You can stay here and we'll just chat about your answers and then I'll go visit somebody else. What did you think?
Dr. Logan.
Yeah.
Zoom just threw me out of the class, so I just joined it back
Uh-oh.
when I was going to my breakout room. So I don't know if you want to send me over there or...
Sure. You know what?
I'm happy I'm not the only one. I actually got kicked out at some point earlier when I had to come back from my breakout room. Like
my
the
gosh.
first one, it just like kicked me out of Zoom and I panicked. So I'm glad it's not just me.
Oh, that's so strange.
I was in breakout room number 4.
Okay.
But yeah, Zoom has been crazy today.
Yeah, I bet. Yeah. It's all sort of wild. I'm monitoring breakout rooms now. It looks like everybody's got at least one other person in there. So why don't we just chat here about these results? Is that okay with you all?
Yeah.
Okay.
Let me pull.
How about number 1?
Are you willing to share your screen again? You said to write everything down and I accidentally only saved the questions, but not the charts themselves.
Ah,
Okay, sorry. And I'll
that
take a
makes
screenshot
sense.
of that now. I like
Knowing that that's the
missed
case,
it.
I'll probably up people's time by a couple of minutes.
Sorry.
No, I just realized that, of course, you could jot down the questions, but it's harder to jot down the results. All right. Let's just skip to number 2 because I assume that you can both look at and figure out which numbers are the same and different. So did the coefficient for the variable we recentered change?
Okay, I was confused about this. The coefficient is just the slope, right?
Mm-hmm.
So no, because the slope doesn't change, it just adjusts, right? It's the y-intercept that changed, which makes sense because you're moving the whole thing, right?
Yep. That's true. What do you think, Raphael? There's a lot you can say about this question. So
I don't know what else to say.
it doesn't change. So the slope that relates inside with the outcome, inside with going out, is the same.
Oh.
Because the 0 point on find info is still the same.
Okay.
Does that make sense? Remember, when you're interpreting inside 10, you're interpreting that coefficient when the other predictors are 0.
Okay, yeah.
So that leads me to the next question, which is, did find information change?
I couldn't understand why it changed. Or I think it changed because it was negative 0.66 and now it's positive 0.18, but I couldn't figure out why.
So why would it change? It has to do with what I said a second ago about how you evaluate the answers to your questions. Like how you would think about the regression equation. And why did one of those numbers in the regression equation change when the other one didn't?
Like I understand why constant changed.
Uh-huh.
It
Why did
changed.
the constant change?
So it changed, I think, because the constant is the y-intercept. So it's where your line, it's where your line crosses the y-axis. So if you center something at 10, it just shifts your line, which means that you're going to cross the y-axis at a different point.
Yes. Use the same logic to think about why would this value change? What does it represent? 0.018. What does it represent for negative 0.06?
Then now we're going to have a reduction, and before we were having an increase.
Yeah. Why is it different?
Because we are not anymore like working with 0.
Uh-huh.
Like now we have I don't remember what was it, 10 as the point, and so like the intercept, it's going to move.
Yes.
Okay.
Wait, I just had somebody ask for help. So talk through it again.
Okay.
See if you can explain that so that you and Nina can get on the same page about it. I'll be back in a minute.
No.
Hey, Dr. Logan.
Hi.
Hi.
Can you give us screen sharing privileges? Because I'm really struggling with making the line graph, and I don't know what I'm doing wrong.
Okay.
And I think that we're having the same problem.
Try now. And if that doesn't work.
Okay.
Okay, it looks like I can.
Oh, you can? Okay. Cool.
All right. So, hi, you're already in this room. Okay. So this says, okay, so do you see how my chart at the bottom, it just says 1 and 2?
Yes.
Okay, I don't know how to change that. So
Yeah,
when
we
I
can change it.
click on this one and do format access, then
It's not
bounds comes up, but then this one, when you go to format access, like I don't get that.
So what you actually need is select data.
Okay.
Oh.
When you click there, click the select data button.
Okay.
And then see how it says horizontal axis labels?
Okay.
Yeah.
So click there, edit, and then you can pick your horizontal axis, which is -2 and 6. And just slide across. There you go. And hit OK.
Wait, what?
Uh-huh.
So is it still giving me like a whole range, or is it just showing those as 2 points? I mean, is it, you see what I mean? Like how over here it has like all the lines and the numbers.
Yes, it's only showing 2 because you're only graphing 2 right now.
Okay.
You could graph lots more, but it won't matter because it only takes 2 points to determine a line. So your line will always be straight.
Okay.
Oh.
But yes.
But but this side of it, the y-axis, is that pulling from the 6 and the 10 over here?
Yes. Well, the y-axis is the outcome. So that your minimum here, it looks like it's about 6. Your maximum is 9.
Okay.
So one of those lines is your values when your other x is 6, and the other one is when your other x is 10.
So if I change this to 5, I'd be able to see it better.
Uh-huh.
Okay.
I just realized something. Were you able to answer the 3 questions?
I don't know. It's like I got so lost at making the chart that then my brain shut off for like what this is really even showing me. I got really lost.
Yeah.
Oh no, I'm sorry. Yeah, okay, that makes sense. So
I have lines, but I don't really know what they mean at all.
So could you don't know what they mean at all. So what you have here for inside, right now you're saying an inside of -2 and an inside of 6.
Okay.
So what do we have graphed here?
Put 6 and 10.
Have graphed where? Sorry.
So
Here?
you have for info, your two values of info that you have. So just put info of 0 because that's what
Okay.
you actually have in this model right now is info of 0.
Okay.
And then on this right graph, the original, you have inside when inside is 0. So that's the first value.
So I have to put 0 here
Mm-hmm.
versus -2. Okay.
Wait, you guys, the values for the second one are 7.036, right? Wait, so you should put 7.30.
Yeah, I have that there.
No, put it in the first column there.
Oh yeah, this is my
Yeah.
fault. I shouldn't have typed it in. I should have typed in the formula.
Oh, yeah. Okay. That should be
Oh
equal.
no, wait 1 minute. Oh, okay. Oh wait, I put it. Okay, got it. Yeah.
Like that?
If these are the values, did you change the other one too? 1018? Yeah.
Yeah.
56, yep.
The other ones I changed. I just forgot to put that one. Okay, that makes sense. Okay, so
We just have to find like a value where they seem to intersect with one another.
You can. Yeah, that's one thing
You
you
don't
can
have
do.
to though, right?
No, you don't have to.
so this is when. So we centered inside at
10.
10. So 0 equals 10.
Yep.
I'm confused.
Yeah, 0 equals 10, but that doesn't matter. It's just 0.
Okay. Okay, it doesn't matter for like the range of data that we have. I think that's why I put a negative number there was because some of our data were negative numbers.
You definitely
Oh,
can. Sorry, I thought you were
Okay.
still doing the original.
okay.
Oh, no. Yeah, no, I'm trying to do the, so that's why I saw some values that were like -2, so I put that as,
Yeah.
but then that doesn't make them look as much like, and then info, what were our values that could even go in for info?
I think it
So-
was.
1 to 4?
I'm going to tell you.
For inside, right? Yeah, can you guys tell me what the range is?
For inside, the range was 2 to 18.
Okay.
18. But then we centered it at 0.
It's not centered. Yes. So 0 means 0.
Oh,
Oh.
okay. So this could go as
Well, if
low
we're
as 2.
centering it at 10, Dr. Logan, can we still put just 0 and like 8 or something?
Well, let's see what inside. What was the range of inside? The range of inside was also 2 to 18.
Okay. But even if we centered it, we can
I
still.
thought one of them was 1 to 4.
I summed them all together.
Okay.
Okay. And what
So
about
it's
info?
actually it's 2 to 20 is the other one. So find info goes from 2 to 20. The other one goes from 2 to 18. So they're both very similar.
Okay, but when we center inside, what should we put as the range after that? Still 2 to 18. After we get inside 10, what does 2 to 18 mean then?
-8 to 8.
Oh.
Yes.
Okay.
Okay, got it. You just subtract. Okay.
Uh-huh.
Got it. Yes, now I see. Now it's intersecting.
-8 to 8.
Yep.
Exactly.
Nice.
Okay, I'm going to bring people back.
Okay.
Cool.
Okay, bye.
Out of town, there'd be the day where it's like, okay, I need someone to come let my dog outside and take him to pee because I can't leave campus.
Look at your dog. Oh, so cute, Hannah.
He
Oh
shows
my
off for the camera. He knows that he has adoring fans, and he does this in all my work meetings.
Just has to be in your lap. Okay, so let's talk about these questions. They seemed pretty straightforward on the surface, but if you start to think about them, they're a little bit more complicated, I think, than you may have expected. So, oh, where'd you go? So, as you have looked at these, let's talk a little bit about, I assumed that you could all determine which ones were the same and which ones were different. What about number 2? Did the coefficient for the variable we recentered change? Can somebody from group 4 tell me whether they changed?
The constant and the slope of found information changed, and the slope of inside and of inside and the interaction term didn't change.
Right. So these two didn't change, but these two did change
Yes.
between the two. So the slope for the variable we actually centered did not change. Were you able to answer why that was the case? Or was that harder to answer than you thought? Hmm. We've only centered the variable but not changed the relationship. That's correct. And so, for example, when I change, so this is the old equation that we were working with before. We're just subtracting something arbitrary, yes. I like this putting information in here. We've got a couple of equations. We've only centered the variable, we haven't changed the relationship. So right here, the relationship, I'm gonna just actually, look at this. I realized one of the things I was doing that was a little bit confusing is I'm already giving you 2 lines at the beginning. The only information you have is about 1 line. You have information about when one of these is 0, not the other one. So if I change this from 0 to 10, if I make it longer, this slope is changing, but the slope is the relationship of info with the outcome. Even though I'm changing this number of inside, as I recenter that, look, there's that value. Do you see it? 7.031. That's our new intercept. Because when inside equals 10, our expected value on y, when information is 0, is 7.031. So as I recenter inside, it doesn't change anything about inside. It only changes information about how info relates to inside. That, what did I just do? Oh my gosh, I typed the wrong number in. 10. Okay. 7.031. There it is. Close enough. Some rounding issues there. All right, so thinking about the graphs we made, I just answered that because I did it. I put it in there. We can draw lines representing these relationships because if you can recenter this at 10, this is the relationship when it's 0, and this is the relationship when it's 10. So that's how you can get the lines for each one on your graphs. Okay. We are just about done. The last thing I have for you today is one more application of this on your own. And I didn't do it as a quiz because we had a little bit of an issue with the Carmen quiz last time. So I have another result for you to answer 4 questions about that I'm going to do the same thing that we just did just now. I will give you 6 minutes to think about it, and then I will put you in breakout rooms to answer the questions about it. And so, I don't know if you remember this one, this example of the Internet News Questionnaire, which is the number of topics people get their news about from the internet online. And I'm predicting it from education level. Low is less education and high is more education. And I'm predicting it from party line. Low is more Republican and high is more Democrat. And I'm going to include the interaction between education and party line, which lets us ask, Does education level moderate the relation between political leaning and internet news? So here is the resulting coefficients table. Here I have information about the predictors, party line and education, and internet news is the outcome. I have 4 questions for you. Get as far as you can in 6 minutes, and then I'll put you in groups. Okay, sending you to go discuss.
Hi.
Hello. Uh-oh. I'm just letting everybody know what to do, so. Oh, if we're just alone, I can send you somewhere. Let me see
Yeah,
if I
I'm
can
really
share.
sorry. I don't know why I'm not going anywhere.
Oh, that's okay. Hang on a second. I will figure it out. I'm gonna send you to a room that only has 2 people in it.
Okay.
Okay.
Doctor, can you let me share my screen?
Is it not working again?
No,
Do I have to be here for you to share your screen?
I don't know.
I don't think so.
No,
I
you
think
just
you just have to give us
like,
the
let me
power.
do it.
We had the power the first time you gave us breakout rooms.
Yeah, and then it just got disabled for some reason.
I don't know. I have not changed any settings.
Oh. Oh, it says host disabled screen sharing when I try.
It says all participants can share.
Oh,
How about now?
okay. No, it still says disabled.
Shoot, I don't know what to tell you. I haven't changed anything. You may have to share a screen like this.
Oh.
I know that stinks.
Yeah, he did it in Excel, which
Yeah.
kind
Okay,
of
wait,
like it was gonna be good for me to
can
see.
show you how it looks though, for sure. So I had.
Dang, I'm so sorry.
No, you're
I'm
fine.
trying to broadcast
You're
something
fine,
to
don't you-
everyone. Let me.
Don't worry.
Okay, well, I have a regression equation.
Oh, you do?
Yeah.
Cool.
So I have y, which is internet news, right?
Mhm.
Equals 3.721
Yeah. Minus
plus or minus
minus
0.458
into
times
party.
party line. Yep.
Yeah.
And
Plus-
then 191 times education.
Yeah, plus 0.058 into the interaction term.
Yep, got that.
Yeah, and
I
then
didn't. How do I rephrase that question to make it more accurate? Is it the problem is the word controlling for?
so we're controlling for so we're trying to see if 1 minute, does the strength of relationship between political leaning and internet depend on education level? Okay, so that means does the education level moderate the relationship between how Republican or Democratic you are and how much internet you use?
Okay.
Or,
So it's the word controlled. So does education level moderate is a better
yeah.
question.
Yes.
Okay.
Mm-hmm. That would work.
I got this.
Ooh. 1 is negative. What
Oh,
are your
yeah.
2 lines?
Oh, 1 is oh my god, okay, wait. 1 tells you the thing for a Democrat, right? The blue one will tell you it for someone with less education.
Uh-huh.
That's the one on the bottom. And then the one on the top will tell you whatever it is for the one with more education. And then on this end, it would be the Republicans, and on this end, it would be the Democrats.
Yeah, so for who is there a bigger difference?
The
Between
Democrats.
educated and uneducated. The Democrats.
Democrats. Well,
Isn't
that's
that wild?
actually quite accurate.
Isn't it wild?
Yeah.
Oh my
So
gosh,
if I don't use, so if I'm not graphing it and, so if I don't graph it, because that's what I'm struggling with, can I also just put those numbers in my regression equation and like get 2 answers?
Yeah,
Okay. Because
that's
that
actually
was all, that
probably,
would,
that's exactly what the Excel does.
Graph is.
okay.
Yeah.
I, for some reason, like I'm not confused about the questions, but then I am confused about the Excel and the graphing part. And so I'm thinking if I just like leave that part out and just answer.
Like when you put in the stuff, right? Like when you put in the formula, It
I
gives
was
you
always really bad at geometry and really good at algebra.
it
So
just
maybe
gives
that's my
you,
problem.
it just gives you like each value, right?
Okay.
Like it
Right.
gives you 4 points, so then you can plot 2 lines on a graph using those 4 points, and
Okay.
that's what it is.
Yep.
Yeah, that doesn't help me. But when I look at it
It's just
in the equation, like it makes perfect sense. So
Oh, good.
maybe I just stop with.
Yeah.
You could just stop there. Yeah, that's fine. For
Okay.
some people, visualizing it is the only way to make them understand. And for
Yeah.
other people, it's absolutely not. And that's totally
Yeah.
fine.
So for number 3, I said that party line has a significant negative relationship with the internet news
Yes, but you're not done
Yes.
with that sentence.
because the more Republican a person is, the less likely they are to read internet news,
controlling for their education, right?
controlling for their education.
Nope, it's not
No.
controlling for. It can't be controlling for.
Accounting for the interaction between.
Nope, remember, we have to locate it in space.
Oh,
Okay, so for a person with
no education.
no education.
Yes,
Okay.
exactly. Instead of saying controlling for, now we have to locate it in space.
Got it.
Because remember, as you change one value, all the other stuff changes too.
Mhm.
Okay.
Got it.
Oh yeah, cool. Did you all get the broadcast message that said when you're done you can leave?
Yes.
Okay, I wasn't sure if it sent.
It did send. I wasn't looking at the screen.
Okay,
I saw it
I'm-
like blue there at one point. So.
okay, I'm gonna go back to the main room so I can catch anybody
Okay,
who's
cool.
trying to leave. But
Okay.
nice job, y'all.
Thank you.
Thank you.
Yeah, bye.
Okay. See ya.
Hi.
Hello.
I called this a homeroom, which I think it isn't. But we can call it a homeroom. It's kind of what it is. It's like
Essentially, yeah.
our home. How did this go? Was this easier than the one before?
Yes, much easier.
Yeah, there's no centering involved.
No.
Yeah, that makes it a lot easier.
Monica and I had a question off of the graph from the last one
Sure.
that also relates to our homework. So for number 3 in the last one, you were like, well, it's just confused you because we included the orange line, so just forget about the orange line.
For a moment.
For a moment.
Just for a moment. Yes.
Okay. So how do you want us to graph it in our homework? Do you want us to just randomly pick 2 points and give you a graph, or?
Yes. Yes, exactly.
Okay.
Just like I did in this question. Hold on. Where I said a poorly educated Democrat and a well-educated Republican. That's only 2 points. You would need 4 in order to graph your line totally. So you would need to have a poorly educated Democrat and a well-educated Democrat, and then a poorly educated Republican and a well-educated Republican. And with all 4 of those, you can graph 2 lines.
Okay.
So, but that was just me picking points to compare. And so if you haven't done that yet, I might suggest you do that right now so you can see who is more different. Are Republicans who are poorly educated and well-educated, is that difference bigger than Democrats who are poorly educated versus well-educated? Did that question make sense? I'm not sure it did.
So
I can
it'd
ask
be
it
like,
a better way.
just make it like the table that we just did. And then we would plug in 1 and 7 for all of the values. So like it would be like 1 and 7 for like party line, and 1 and 7 for education level, and that would give us 2 lines.
Yes.
And that's what we would throw in the homework.
Yes. Exactly.
Okay.
Try plugging in the other 2 numbers right now. You should be able to get the answer because it's just plugging them into your regression equation, which you answered for number 1. Who just asked me for help? Ari, was that you?
It was, yeah. So Justin and I were having trouble with number 3. I don't know if we misunderstood the question or if we were having trouble thinking about it.
Probably it would be easier if I used the whole sentence, which would be interpret the coefficient or slope for party line in a sentence. Is that a better
Okay.
question?
No,
that was not the problem. What was the problem?
I don't know. We were having trouble because there's no 0, right? So we were confused about what happens, like, because we always start off by like, okay, this is the expected score for someone who's 0 on all of these things, right? And that gives us our constant, but we didn't know how to conceptualize like not having a political leaning, or there was like no possible 0. So I think that's where I was getting hung up.
You're exactly right, but that is still what it means. It still means when it's 0. You have to add to that, which is impossible. So it can't be 0.
Okay.
So you're interpolating
Okay.
outside of the actual scope of data
Gotcha.
when you're
Okay.
trying to interpret it at 0. No
So
one
that
is
was
going
the
to
correct
have.
conclusion.
Yeah. Yes.
Okay.
Uh-huh.
Okay.
So you had it exactly right. So yay.
Okay. Yeah.
Oh,
Yay.
I didn't get to watch Justin's face
It's a
when I
win.
said we got it right.
All right. Thank you.
Did you all do, so you just did 2 points, right? You did educated, a poorly educated Democrat and a well-educated Republican. So
Yes.
who has a more higher internet news score?
I don't remember. Justin had a really nice graph though, and a really nice
The
spreadsheet.
the highly educated Republican.
Gets more internet news online
Yeah.
as opposed to internet news not online? What is that, like printing it out? Yes. And so did you do the whole graph?
Yeah. Is it set up to share?
I think so. Yeah, try it. See if it'll
Okay.
work. Although somebody called me into a breakout room and it wouldn't let them share, so I don't know. It's working for you. Hey, look at that. Oh my gosh, that's so cool. I love data so much. Okay, so which one's which? Do you know?
Probably this one right here. So the orange is the I guess the educate.
Yeah, the highly educated people.
Yeah.
So for people who are highly educated, what's the difference between Democrats and Republicans?
0.3 something, very, very little. So just looking at that would probably be like non-significant since it's so close to 0.
Yes. How would you know? How would you know if it was non-significant? What could you do to figure it out?
I'm looking at the p-value.
What p-value?
Well, I'm interpreting just a random p-value.
We don't have that right now, do we? We don't have that slope. Who's that the slope for? I already said it. It's the slope when education is 7.
Mm-hmm.
And right now that's our slope for relating Republican party line. That's our slope for relating party line to internet news when education is 7.
Yeah, so if we go back to number 3, you were talking about making sure that was 0. So if we were gonna do that, we would come in here and change that to 0, which you said was outside of the data. So we would be interpreting that when education is 0.
Uh-huh.
Yeah.
But if we wanted to see if that slope was significantly different from 0, Abby, you looked like you had an epiphany. If we wanted to measure whether that slope was significantly different from 0, Justin, you hypothesized that it wasn't because it's so similar. How could you test whether that slope is significantly different from 0? Center it, center it. Where would you center it?
You'd center it at 7.
Yes! You would center it at 7. Because then the significance test would be about when education is 7. But which number would change? The constant would change, for sure. What other number would change? If you center education at 7, these say inside and info, so that's not very useful. But looking at the coefficients, the party line slope would change. Yeah.
Yeah, because opposite last time. those opposite lots. So in the other example, like we changed inside and info changed.
Uh-huh.
Yeah.
And if you look at the party line slope right now, it's negative 0.458. So that's what's represented here, negative 0.458. It's going down as education goes up. When education is 0, party line is going down. As party line goes up, the association changes. None of that made sense. Let me do that again. As party line goes up from 1 to 7, the expected score on internet news is going down. So there's a negative slope of around 0.45 when education is 0. But when education is 7, that slope is pretty close to 0. So if you change that, the slope that now reads negative 0.458 would be something else. And the significance test would test the significance of that slope from 0. I feel like you all got it, and then I tried to explain it, and I made it worse. Story of my life. Okay, that was really fun. Okay, other things about this. Thank you for sharing that. I really appreciate it, Justin. That was really great to see. No other things on this? Okay. Well then, anybody else have a pet to hold up? I've already said I don't have pets. I do have a jack-o'-lantern looking thing next to me today. That's the closest I get to a pet.
I have a pet, but she's sleeping and she gets grumpy when I wake her. So I'm gonna not do that. She's like a toddler.
Mine's in the other room. I don't have pets, but I am sitting right next to 2 glass doors. And I have a bunch of hickory trees, which means I have squirrels and chipmunks. And right now, with the rain and the wind, it's causing nuts to fall, and then squirrels go chasing after them. So I keep hearing like things dropping in the background and then like things scurrying after them.
Oh my gosh, that's amazing.
Earlier today in the lot next to me, which is all wooded, a tree had already broken half. It fell the rest of the way over. So there was just like this loud, like, that was a big branch. And luckily, like, I mean, wooded lot. But yeah, so I just have squirrels and nuts constantly like falling.
Like a constant drama at your house.
Yeah.
That's amazing. Wait, I'm going to stop this recording. Bye, everyone.